if x is equal to 2.536, if x value is given, find absolute error and relative error if x is truncated to 2 decimal places. Okay, now this is homework for you. Hint, true value is 2.536. okay, truncated value means 2 decimal point, up to 2 decimal places, means after point we have to consider only 2 decimal places, that is 2.53 is a truncated value. So take the difference, we get error. Take absolute value, we get absolute error, and calculate the error, relative error and percentage error also. Okay, calculate percentage error also, just multiply by 100. Now next, round off the number 865250. Now in this example we have to round off this whole number. In this particular number, decimal, this is not decimal number. Okay, this is a whole number. Now how to figure out, how to find out the significant figures of a particular whole number, let us see. To 4 significant figures we have to round up this number and find absolute error, percentage error and relative error. Okay, now round off the number to 4 significant figures means we have to consider the 4 figure 8652 and add 00 to the rest of the other numbers. That means there are 2 zeros only here. That's why this is called the round off figure, round off the number to 4 significant figures to whole number. In earlier example, this is there is a decimal place. In this example, decimal place is at here. It's a whole number. That's why a round off the whole number means this step. Up to which place they are asked, just take those 4 digit or 3 digit or 5 digit and add zeros to the next all digits. This means round up the numbers to the particular significant figures. Okay, this is the only difference. Rest of the terms are as it is. Approximate value is this. Okay, now true value is this. This is approximate value. Taking subtraction we get error, that is 50, and absolute error is modulus of 50 is 50. Relative error is nothing but this. A percentage error you can add. Percentage error is equal to 5.77 into 10 raised to minus 5 into 100, which is 5.77 into 10 raised to minus 3. Okay, now let's see next example. The height of an observation tower is estimated to be 47 meter. Okay, this is observed value of tower, and whereas actual height of the tower is 45 meter. Calculate percentage error. Okay, true value is 45 meter, actual value means actual height means true height, that is true value 45, and observed means measured or observed value means approximate value is 47 meter. Now error is nothing but true value minus approximate value, which is minus 2. Okay, now absolute error is absolute value of error, that is minus 2, absolute value is 2. Relative error is absolute divided by true, that is this value, and percentage error means multiply by 100, we get 4.444 is our answer for percentage error. These are very simple examples. Now let us see next some definitions. Machine epsilon. Computer has finite word lengths, okay, and fixed number of digit are stored in that particular memory, computer memory, and those memory are used during the computation or calculations. Hence, even in storing an exact decimal numbers in the converted form in the computer memory, means computer is limited to particular memory, and that is the only thing which occurs an error while calculating the while calculating the answers. Okay, and that particular error is introduced is nothing but which depend on the machine. Okay, it's called the machine epsilon, and it is only depend on the base, beta and number of digits. This is the only theoretical explanation for machine epsilon. Now, data uncertainty. If data contains large inaccuracies or impreciseness if data itself consists of that number of inaccuracies and impreciseness, maybe due to the problem in measuring the instrument. If suppose particular instruments are, if like for example in earlier example measuring a tower height, we are obviously we are going to use some instruments, and that particular instrument itself consists of a large number of inaccuracy or impreciseness. This will directly affect the quality of result, obviously. That's why statistical analysis on the data helps to minimize these types of error. It's called the data uncertainties. Now let us see. Mm, it is a homework for you. It is very simple. The and measuring length of breadth and rivet. We are measuring the length of the bridge and the rivet are 9999 and 9 centimeter. 9999 is the length of bridge and 9 centimeter is the length of rivet respectively. Okay, whereas true values are, whereas actual values of the length of the bridge is 10,000, it is 9,999, and actually is 10,000, and for length of the rivet is 9 centimeter, which is observed value, and actual value is 10 centimeter. And find the percentage error. Okay, this is a very easy example. This is homework for you. Percentage error for bridge is this, and that of rivet is 10%. Okay, calculate separately. This is the only example. Now error propagation. Error propagation is nothing but, suppose we are calculating area of a triangle, suppose, okay, in particular suppose area of a rectangle, suppose, and if we for while measuring the length and breadth of the rectangle, if we do some mistakes, then errors can occur in measuring length and breadth, and ultimately we get error in measuring the area. Such type of errors, calculating the errors, is nothing but the error propagation. And what is the theory behind, what is the formula behind error propagation, is nothing but, like for example, let us see, u is equal to x plus y, means u is a function of two variables x and y, means u can be calculated by using x, measurement of x and measurement of y. And if suppose x and y have the errors del x del y, then ultimately there is the error to measuring for the calculation of u, that is called del u. These are the errors. Then error propagation gives the resultant relative error in the measuring in the measuring u is nothing but del u upon u is equal to del x upon x plus del y upon y. Okay, separate, calculate the separate error and add. This is the formula. Let us see the examples depend on this. The length and breadth of the rectangle are 5.7 plus minus 0.1 centimeter. This plus minus means the error, and 5.7 is nothing but the actual length, and 0.1 plus minus is the error, and length is this, and breadth means the width is 3.4 plus minus to 0.2 centimeter. Full stop. This is the given thing. What we have to find? Calculate area of the rectangle. Now in such type of example, you have to know the formulas of area of a rectangle. They can ask for area of triangle, okay, area of any geometrical figure. You have to by earlier knowledge you have to know, you should know. Now area of what we have to do in this particular example, area of calculating area of rectangle with the error limit. Error limit is nothing but this, plus minus whatever is the number, this is called error limit. Now let us start with the, this is called the error propagation. Let us start with the answer. This is a rectangle, this is obviously length, this is breadth, that is width. Length is given, suppose L is a length, B is a breadth, or width. Length is given 5.7 plus minus 0.1. B is 3.4 plus minus this with this limit. Okay, 3.4 plus minus 0.2. That A is the area of rectangle. Now we know well a formula for area of a rectangle. Ayat. Okay, ayataचं क्षेत्रफळ लांबी गुणिले रुंदी. That's why A is area of rectangle is length into breadth is nothing but L into B. Okay, now given del L. Del L means error in length. Is this error limit 0 plus minus 0.1 centimeter, and del B error in B, that is 0.2. Okay, now area of a rectangle without error limit. We have to calculate area of rectangle without error limit, that is A is equal to A. This we need in our formula. A is nothing but L into B, length into breadth. Length is 5.7 into 3.4. This is the area, actual area without this limit, without this error limit. In calculate on calculator we get 19.38. Obviously area unit is centimeter, which is given in the centimeter square. Okay, this is actual area. Now we have to calculate this area which is given with the error limit. Now area of rectangle with error limit calculated as follows, that is total relative error we have to find out first. Total error limit is equal to sum of the relative error of the individual error measures. Okay, that means del of A, that is relative error of rectangle, area of rectangle is nothing but del A upon A is equal to, using this formula. Okay, del A upon A is equal to del L upon L plus del B upon B. Now take A on that side, we get del A is equal to, which is the our actual answer. Del A means area of rectangle with error limit. This A comes to the RHS side, A into this term. Now put the values. A is actually area. This we have calculated already without error limit, 19.38 into del L is 0.1 upon L. L is here 5.7 plus del B, that is 0.2 upon B is 3.4. Calculate on calculator. Answer is 11.48 centimeter. Obviously it is also area centimeter square. Therefore area of rectangle with error limit is nothing but A plus del A. Now here one more formula. After calculating this error, resultant error is nothing but U plus del U. Whatever area, whatever error you have calculated in U, just add to the original U. That's why area of rectangle with error limit is nothing but A plus del A. A is our area. A is 19.38 plus minus, we have to do it plus minus. Okay, like given in the example itself. Plus minus del A means 19.38 plus minus del A is 1. It is 1.48 only. Okay, centimeter square, you can centimeter square. If unit is given, you have to write unit also. Well, let us see one more example. A body travels uniformly at a distance of this 13.8 plus minus 0.2 meter. In the time is given 4.0, that is 4 plus minus 0.3 second. Yes, 4 second time unit. Find the velocity of the body with the error limit. Now we have to find velocity of the body. That's why we have to know the formula for velocity is nothing but distance upon time. Okay, now let us start. Let S is equal to distance, which is given 13.8 original distance meter. Del S means error limit of S is 0.2 meter. T is the time, suppose it is given 4 second, and del T means error, that is 0.3 second, which is given. Okay, now velocity we know distance upon time. That's why V is equal to, let V is the velocity, S is the time, and T is the S is the distance, T is the time. Calculate first original true value, that is V is equal to S upon T. S value is 13.8 upon T is 4. which is value answer for this is 3.45. Obviously velocity unit is meter per second. This is meter per second. Okay, now we have to calculate the error in v. That's why formula is del v upon v is equal to del, how many variables are there? Two variables, yes and distance and time. That's why separately we have to add, this is error propagation, del s upon s plus del t upon t. Therefore del v, put v on RHS side, v into this term. Okay, now put all these values here which is given in the example itself. We get this v as it is, del s upon s plus del t upon t. Calculate on calculator, we get del v, that is error in v is nothing but plus minus, we have to take plus minus like in this example 0.3, okay, meter per second obviously. Now velocity with error, we have to find out velocity of the body with error limit. With error limit is nothing but v, original v plus this del v. Original v is nothing but this 3.45 plus minus we have to take 0.3 obviously meter per second. Okay, now this is our first chapter. Now in this lecture we have seen the error, types of error, error propagation, different truncation error, round off error. Okay, just we'll continue in the next lecture.